Hello and welcome, everyone. My name is James Blair. I'm a senior product manager at Posit, focused on cloud partnerships, primarily focused on Databricks. Today, we're going to spend some time talking about data engineering using Positron, which is a new developer tool that we've developed here at Posit, and Databricks, and how these two tools work together to complement one another. To set the stage, we're going to talk about a business problem that we can use to anchor our discussion against. I'll provide a little bit of an introduction to Positron and how we plan to use that alongside Databricks. And then the bulk of our conversation today will be spent in a live demonstration of using Positron alongside Databricks to build data engineering workflows and pipelines. We'll have a short kind of comparison at the end of what it means to use a true developer environment or integrated developer tool like Positron versus native features like Databricks notebooks and when you might use one over the other. And then we'll have some time for Q&A here at the end. So let's set the stage a little bit. This will be a bit contrived, and I recognize that, but this will at least help us kind of anchor to something that we can use as a motivating factor or motivating problem throughout the course of this discussion. Let's say that a topic of interest for us is understanding how weather impacts New York City taxi trips, the distance, the fares. How does weather impact some of this? Now, some of you may recognize that there's some convenience to this question, and the convenience is this New York taxi data set is built into every Databricks environment. So you automatically, if you have access to a Databricks environment, you automatically have access to this data about taxi trips in New York City. However, this taxi data does not contain any weather information. It has information like the trip distance and the fare amount and the pickup locations, but it does not contain any information about the weather during the trip itself. So what we want to be able to do is we want to be able to supplement this existing data inside of Databricks with some new data that provides context around weather. And with that new data, we can begin to answer additional questions that we have not been able to access or answer previously. Questions like, how does temperature impact the trip distance? Or how does weather impact the fare of the trip? Things like this. So in order to get there, we have to be able to bring some new data into the equation so that we're not just looking at what happened with the taxi data, but we also have the ability to start to uncover a little bit of why we might see certain things, right? Why were some trips more expensive than others? Maybe it was weather related. Why were some trips longer than others? Again, maybe that's due to the cold temperature or something of that effect. So we're going to use this sort of framework, this sort of hypothesis here to anchor against as we walk through and look at how Positron can help us with these kinds of questions and with this kind of work. In order to succeed here, what we need some sort of historical weather data that we can integrate and join with the taxi data that's available inside of Databricks. And ideally, we'd like this to be as granular as we can. Hourly feels like a pretty good level of granularity, so that we could match the hour that the trip occurred with the weather in New York City at that particular hour. And then we can, if we can define additional characteristics, not just temperature, but precipitation, other weather patterns, we have greater ability to understand this interaction between weather and these taxi trips in New York. So what we're going to do is we're going to work on building this sort of pipeline. If I'm in an organization that comes to me and says, look, we have all this taxi data, but we want to understand the impact of weather. And this could be anything else, right? This could be, we have a bunch of demographic data and we'd like to add X, Y, and Z. We have a bunch of loan data and we'd like to supplement it with this. And I think this is a fairly common request of, we have our existing data inside of our data lake or inside of a warehouse somewhere. And now we've decided that we want to add or supplement that with something new. And maybe we already know the source of what that new data is going to come from. Maybe we need to go and explore and figure out what are some viable sources. But regardless, there's this process sort of in the beginning of, what does our existing data have? What do we need or what are we missing? Where can we find it? And then how do we pull those two pieces together? Once we've figured out how to pull those two pieces together and combine them into one sort of bigger picture, how do we create some sort of reproducible way of doing this? How do we build a pipeline? How do we build some sort of workflow that will enable this to take place over and over again as new data is introduced so that we have current, up-to-date, reliable data that supplements the existing data inside of our warehouse? To do this, like I mentioned at the beginning, we're going to be using a tool called Positron. In fact, we're already there. And some of you may have noticed these slides are being given out of Positron itself. So we're already in the IDE. We'll expand to other features of the IDE here in just a moment. But what Positron is this is a next generation developer tool that we've built here at Posit. We're very excited about what Positron offers. We've been working on this for a long time, and we've been very excited over the past couple of years to really start bringing this into the spotlight and showcasing the hard work that's gone on behind the scenes. The thing that makes Positron unique, and again, we're already in Positron here as we're talking, is this is built on top of VS Code, like many developer tools are today, built on top of the open source components of VS Code. But we've taken everything that we've learned as a company and organization in our experience of building RStudio, the premier developer environment for our developers. We've taken all the lessons learned building RStudio and applied them to this multilingual developer tool that's very, very focused on data science and analytics. What that means is, while VS Code provides a very robust tool for sort of software engineering, a lot of times people will sometimes refer to VS Code and similar tools as very fancy or complex text editors, which they are, right? And then they're supplemented with extensions and all these other things. But at the root of what we're doing, we're manipulating text, we're writing code, and VS Code provides a lot of useful functionality around working with lots of files and mapping dependencies between them and all these things. Data science is a little bit different, and working with data is a little bit different, because in many cases, you're not just writing and then compiling something static. Instead, you're working in sort of an interactive environment, whether it's Python or whether it's R. I have some sort of running process, and in that running process, I'm loading libraries, I'm adding data, I'm exploring, I'm generating plots, I'm making visualizations. So there's this very sort of rapid feedback loop that's happening when I'm working with data. And one of the things that made RStudio so successful for such a long time, and this is not, for those of you that are users of RStudio, this is not a signal that we are abandoning the RStudio project or deprecating that in any sort of way. We will continue to maintain RStudio. That this is not a change of direction. Rather, this is merely an expansion of the tools that we provide. But one of the things that's made RStudio so successful is this idea that I have an editor and I have an R runtime that's actively receiving commands from the editor. I have an environments panel where I can see what I've loaded in my environment, what data objects, what variables, what things I have access to. I have a packages pane. So I have all these different things that sort of help me through this fast cycle of thinking of a question, writing some code, executing it inside the R runtime, looking at the results, and then repeating over and over again at a very, very high iterative speed to sort of hone in on some sort of specific conclusion. And while we often think of that process as very focused on data science, I think there's actually quite a bit of overlap with that idea and data engineering, particularly when we're exploring a new data source or a new component or a new set of data that we want to join to existing data, like what we've described here. So Positron is, again, built on VS Code. It has native support for R and Python. There's other things that we plan on adding support for in the future, SQL and some other things. And there's also native support for all the whole ecosystem of VS Code extensions. So the Databricks extension works inside of Positron. Other extensions that you might know and love, having used VS Code, work inside of Positron as well. So you get the benefit of this vast ecosystem of tools inside of VS Code with the added benefit of native R and native Python execution that's built into the product itself. Okay, with that little bit of an introduction, let's jump into a demo here. So again, we're already in Positron. I'm just going to minimize this sort of side panel over here that has our slides. We'll come back to these in a moment. This is what Positron looks like. We're not going to spend a ton of time kind of orienting ourselves here, but again, if you've used VS Code previously, you'll recognize that this looks and feels a lot like VS Code. One of the things that's a little bit unique is that I have this console down here that has currently a running Python session. And if I wanted to start another Python session, I could. If I wanted to start an R session down here, I could do that as well. And now I have both Python and R running concurrently. And as I switch between the two of them, Positron recognizes like what the active interpreter is. And so my environments pane, my session panel will show different details. So here's R452, here's my Python environment. So some nice things here that just make it easy for me to quickly move between the different parts of exploring and working with data. One of the things that's new to Positron that we'll highlight here is this catalog explorer. So over here on the left-hand side, I can choose this top icon, which allows me to view my file system. But down here at the bottom, there's this catalog explorer. And in this catalog explorer, I can come in and I can take a look at the different Databricks catalogs and schemas and tables that I have access to. So in here, I can see some different bits of information. If I came into samples, I could come in and take a look at this NYC taxi trips data, and I could go ahead and right click on this and say, let's just go ahead and preview this with Python. I can choose a SQL warehouse that I want to use for the execution here. So we'll say we'll use my demo warehouse. This one I'll fire open, copy some code to my clipboard. I can execute this here inside of my console. And this is going to go open a browser window, authenticate me into Databricks, and then come back here into Positron. And I'll now have this trips variable that will represent, and we can see the SQL statement here, represent the first 1,000 rows from this taxi trips data. And over here on the right-hand side, I can pop this open and I can see different details about the variables that are here. I can click on this icon to explore this. Over here, I can see what's available, what this data looks like. I can get some summary statistics, information about the distribution of different values here. So now I've got the ability to come in. I can connect to Databricks. I can explore what's available there. This is the first half of our problem. We want to understand this trips data. And again, this is available to every Databricks account. So if you have a Databricks account, there's this sample catalog, and in there, there's this NYC taxi schema, and you've got this trips table that's there that you can access. And here we have information like the time of the drop off, the time of the pickup, how long the trip was, what the fare amount was, what the zip code was where they were picked up, where it was dropped off. So not a ton of information, but enough to make this a fairly compelling set of data, and particularly compelling when we start to supplement this with additional details like weather. So now let's turn our attention to that. How do we get weather data into here? Well, the first thing that we need is some weather data. And there's many different places we might look for this. We're not going to spend time today searching for the best possible weather data. But one thing that I do know is that there's a historical API called OpenMeteo, or OpenMeteo, I guess, that supports historical weather reports from different places. And so we can use this open API. It doesn't require a key or any sort of authentication. It's rate limited, so we need to be conscious and good stewards. But we can use this open API to fetch some data that might be of assistance in this particular circumstance where we're trying to add weather data as a supplement to this taxi data. In order to do this, so historically, I could go and I could read the API docs, and then I could come in and I could open up a new Python file, and I could go through and I could send some queries to the API and figure out what endpoint was the right endpoint, and build out sort of step-by-step how I want to access this data and what features of this data I'm interested in. There's nothing wrong with that approach. Right? That's the way that we've done things for a long, long time. However, here in 2026, the landscape of tools has rapidly changed over the course of the past year, and particularly the past 6 months. So we're actually going to turn to a tool inside of Positron called Positron Assistant that we're going to use to help us explore this API. So we're just going to come in. Positron Assistant is an AI tool built into Positron that does what you would expect modern AI agentic tools to do. It gives us access to foundational models. We can see I'm using Claude Sonnet 4.5 here. This is configured to use AWS Bedrock. I could use Anthropic natively. I could use OpenAI. I've got a number of different ways I can configure this particular assistant with the model that I want to use. Here we're using Claude Sonnet 4.5. And the thing that makes Positron Assistant a little bit unique is that not only does it know what files I have and what the contents of those files are, it also knows information about my current session. So I can see here in the context, it tells me that it has information about my current runtime, Python 3.12.9, which is this session right here. So it knows that I have this trips data loaded, and it knows that I've got a connection to Databricks and some other things there. What we're actually going to do, though, is we're going to come in here and we're going to say, okay, let's look at some Python code, and let's write some Python code to go and inspect this OpenMeteo API and just fetch some data from January 2023. And we could adjust this data if we wanted to. We could make the change here, but let's just go and kind of explore this data a little bit. So we'll fire this request off. And this request doesn't really depend on my current session. There's not a lot in my current session that is going to impact this particular request that we have. So even though it's adding that as context, it's just going to say, okay, I'm going to write some Python code that's going to fetch this hourly data. So it's now imported requests and pandas, and it's identified the latitude and longitude coordinates for New York City and reached out to this Open Media Weather API endpoint with this latitude and longitude value, a date range, and it's asking for a few different values from this sort of hourly report: temperature, precipitation, wind speed, and then we've got the time zone defined here. This is really nice, right? I didn't have to write any of this by hand. I could have written this. I can easily review it here, and I can see this looks like what I would have probably done if I would have gone and read through the documentation and put this together. There's nothing in here that appears to be off or egregious to me. This looks like it should work. We'll run this here in just a moment. We'll be able to kind of see the results. And then it gives me a little bit of a summary about what it's doing. We're using NYC's coordinates. We're fetching this thing. So it gives some sort of a response here. And I can come in and say, okay, let's actually run this data. And you'll notice that this ran inside of let's minimize this side over here. This ran inside of my active console. So I can now see that I have this weather data that has come from this API, and it's returning valid values. I've got temperature here. I've got precipitation. I've got wind speed. So I've got what I want, or it looks like I have what I want from this data set here, which is great. This gives me something that I can start to work on. So now that we have that, we could spend some time exploring a little bit further here. If we wanted to, we could say, like, help us explore with a visualization. And I could be more prescriptive. I could describe a specific visualization, right? Maybe we want to look at precipitation and wind speed, or the relationship between temperature and precipitation. But we'll just kind of leave this open-ended. And this can generate code that's going to make a plot, and the plot's going to show up here inside of my IDE. So I have, again, kind of everything that I need. It's going to be mad because Seaborn's out there. This is nice. It'll ask permission to install that package. So it says, okay, you don't seem to have Seaborn or Matplotlib. Do you want to install those? I can choose which level of permission I want to give this. We'll say this is okay. It'll pop open here. I'm using UV to manage my Python environment. So this will use UV to make sure these packages are available here in this environment. Once this is done, Positron Assistant recognized, okay, it looks like those packages were installed. This looks like, yep, Seaborn was installed successfully, Matplotlib was installed successfully. Now let's run this visualization code again, and we'll get this resulting visualization that will appear here inside of our viewer pane in just a moment. So this becomes a really powerful way to quickly interact with and explore new data or existing data, right? We could do the same thing with the trips data inside of Databricks. Here we're doing it with this data that we've queried from this API, but it gives us a very nice iterative way to sort of work through our data in real time. And here's our plot here. And so we've got this nice plot that shows temperature across the month, precipitation across the month, wind speed across the month. So a really nice sort of laid out collection of plots here to understand the data that we're looking at. And I didn't have to open a separate window. All this is rendering inside of Positron. Okay. So now we've explored this data. We have a kind of a sense of what's available. And now we want to start thinking about how we can join this data to the trips data that we have. Now, if we look back at our trips data, which we've got pulled open here, we can see that these pickup times and drop-off times are from 2016. Right, so this 2023 data that we just queried isn't going to help us here. We're going to need data back from 2016, and then we've loaded sort of this first 1,000 rows of this trips data into our Python session here inside of Positron. So what that does is we now have sort of like a little bit of a local sandbox where we can say, okay, let's sort of put together how we can join these things together, see what that looks like, and then we can start to build a pipeline that we can push out to Databricks to build this sort of systematically in a very sort of data engineering frame of mind. So let's come back over to Positron Assistant and say, okay, we have some taxi trips data from 2016. Let's query the weather API again and see if we can join weather data by hour to the taxi data. Okay, so again, we could, based on what we've already received from Positron Assistant here, if we go back up and we look at the data or the query that was sent to the API, we could easily come back and kind of modify this ourselves. And we could say, let's change the dates to align with the maximum minimum date in the trips data. And then let's go through and submit a new query. And then we can aggregate and then join that back to our trips data as we need to. But we can also just come over here and we can kind of describe what we're looking for here to Positron Assistant, and it will start kind of working through what we've described. And we can keep track of what it's doing. We can see that we've got this trips with weather that's now been created, and we can start to see, if we scroll through here, we can start to see how it's put this trips data together. You'll also notice, and maybe you saw it down here, there were a couple of errors that came up as this was going, right? It made a weird join. It had a value that didn't make sense. It threw an error here. But because Positron Assistant has access to the console that we're working with, this Python session, it saw the error, addressed it, rewrote the query, and moved on. And we didn't have to go back and say, hey, this actually created an error. Can you fix the error? It was able to do so automatically. Part of that is because we've enabled this to operate in the sort of agent mode where it has a higher level of autonomy to go and do things. And if we wanted to pull that back a little bit, if we wanted to stay in a little bit firmer control of what was going on, we could change the leveling here. We could say, just ask for permissions for everything, or you do have edit permissions. So we have the ability to change kind of the behavior and the autonomy level that this tool has. So now that we've kind of let this run, let's come over and let's just take a look at our trips with weather data here. So we'll pop this open. So this shows, just like we saw in the taxi data, the pickup date time, the drop-off date time, trip distance, fare amount, pickup zip code, drop-off zip, pickup hours. So now we've created this, we've taken the pickup time and we've rounded that to the nearest hour because our weather data was only hourly. So now we've got the pickup hour, and now we have the temperature at pickup, the precipitation at pickup, the wind speed at pickup. And then we've also created it went above and beyond, as AI tools are destined to do at times. And it's created this sort of temperature category. So is it cold? Is it cool? Is it mild? Like what is the feeling, or what's a categorical definition of the temperature? And a Boolean to indicate whether or not there was precipitation, not the level, but just was there or was there not precipitation, which is great. So now this gives us, kind of proves out this idea that we can do what we set out to do. We can take this taxi data, we can join it with this weather data that we've collected from the API. And if we go back to our original sort of hypothesis here, that allows us to start to answer questions like, how does weather impact the distance that taxis travel? How does it impact fare? Is there the amount of fare that's charged? Is there a real impact there? We can start to look at some of these questions. However, we've only done this for 1,000 rows. This trips with weather is just the first 1,000 rows. And it's not in Databricks. If somebody else wanted to use this data, this is just sitting inside this session, this Python session in Positron. So we're part of the way there. We've proved out what we can do. And the next step is to say, well, now let's define a way to do this programmatically inside of Databricks and on some sort of scheduled cadence in the event that this was a live table. Now, the taxi data is not being actively updated, so it's not like we're getting new taxi information dumped in there all the time. But if this was a true sort of business scenario, then you could imagine that that's what's happening. We have new data that's coming into our data lake, and then we're going to periodically reach back out to this weather API. We're going to grab the new data that's available there and join the two things together to create this up-to-date sort of joined data set that's available. So we want to make this sort of up-to-date joined data set that is regularly available to other users inside of my Databricks platform. One of the ways that we could do this is we can leverage Databricks asset bundles, or DABs. So Databricks asset bundle is kind of at its core, it's this YAML file that helps define a series of different dependencies and configurations of this bundle of resources that we want to deploy to Databricks, and then we can define sort of the behavior associated with that bundle. We can lean on, and just for the sake of time here, we're not going to go through the whole exercise, but we can lean on tools like Positron Assistant to help us create these things. So we can come in and we can say, hey, like now that I've proven that I can join this data with this data, let's create a Databricks asset bundle, which is how we created this one, right? Like let's create a Databricks asset bundle that helps us do this on a regularly scheduled basis. So here we have this Databricks asset bundle, this Databricks.yaml file that provides some details about this bundle that's been created. And in here, the thing that I want to highlight, there's a few different pieces here, but the thing I want to focus on is we have these resources that we're including as well that define a couple of different jobs and pipelines that are part of this bundle. So if I come in and I look at our resources, we can see that I have this weather integration job here that defines a job inside of Databricks that runs daily at 6 a.m., runs every day. It has some parameters around the catalog and schema that are being used, the date that we're starting and ending. These represent the start and end dates of the New York taxi information. And then it goes through and it defines this task to go fetch the weather from this open Medio API. And we're using this notebook that was created that contains just the Python code that we've already walked through to go fetch the data from the API. And again, a lot of this can be rather easily generated using tools like Positron Assistant once we've sort of laid the groundwork, because we have all the context there. We've shown how to grab data from the API. We've shown how to query Databricks and where that data lives in Databricks in terms of what catalog and schema it's part of. So now we just have to kind of put the pieces together in a way that is compliant with this sort of asset bundle, with this asset bundle structure. So this task goes out and fetches this new data from the historical weather. We have a second task that runs the pipeline. And if we look, part of this as well, if we pull this open, if we look at our sort of ETL transformations that we define in here, we're using Spark declarative pipelines or Lakehouse Spark declarative pipelines, I think is the technical term for this, where if we come in here and take a look, we're defining these DP tables that inherently understand data dependencies. So what this does is this allows us to publish this job and the associated pipelines. And then when these things run, they understand what dependencies are needed so that things run in the right sequence and order and fail gracefully if there's an error. And we can look at all this, right? And all this will be on GitHub. We'll share the link at the end. So if you want to kind of explore the different pieces, but if we come in and we look at how we deploy and run some of this. So in here, in our, inside of our project where we have this Databricks YAML file defined, we can simply run this Databricks bundle deploy from the Databricks CLI that will take that YAML file and everything that it defines and the dependencies that it contains, and then deploy this to Databricks. Once that deployment is successful, we can also execute this bundle run that says, now execute that in real time, or execute that, trigger an execution for that. And if we run this, we'll see some feedback here in the terminal that gives us an indication that we've uploaded the bundle files. So that includes all the different declarative pipeline information that we have, as well as the notebooks that define reaching out to the API. And then we can see that we've now started this weather integration. This weather integration job is now running. And if we pop open our Databricks UI here and come over to jobs and pipelines, we can see that this weather integration is currently executing. And I can see down here, this particular flow right here is currently running. We can click into this and see where we're at. So currently we're in that fetch weather data portion where we're running that fetch weather notebook. And if we click in, we can see details about where we're at in that notebook execution. So we can see here each of the different steps. We grabbed 4,368 weather records, and now we're writing that weather to a new table. We're writing it to weather underscore raw. And now that table contains this weather data that we fetched from the API. And if we come back here and we look back at our run, we've now moved on to this declarative pipeline. And in here, we have a number of different dependencies that are currently being mapped out. And then we'll see a number of different inputs here. So we have this the weather raw table gets read in here. We're pulling the taxi trips data, and then we're creating a number of materialized views based on this data that we've pulled in from this Open Medio API. So we have data that we've gathered from the API. We have the New York City taxi data that's already here inside of Databricks. This pipeline is now bringing all those things together and then generating a number of different materialized views. And you might, there's a number of different ways people might look at these views. You might be familiar with bronze, silver, gold layers and levels of data. this would fit that abstraction, right? You could have a gold level of sort of reporting, aggregated information. You could have a silver layer of the joined data, and then you have your bronze layer of just kind of the raw tables that are feeding into these joins. So we see each of these sort of in sequence here, all defined inside of this Databricks asset bundle. And the advantage of that is, if we come back into Positron for a moment, all of this is just sort of standard Python codes. When I look at my weather data source Python file, this is just Python code. And because it's just a Python file and I'm working inside of Positron, I have access to debugging capabilities. I have access to, we highlighted this earlier, but I haven't talked much about it. I have access to the Databricks VS Code extension. So if I wanted to run things ad hoc inside of Databricks as I'm developing things here, we can do that. And I have the ability to use version control and operate in a way that allows me to work really well with this, with the files that I'm operating with, and collaborate with others through tools like Git and GitHub or whatever the case might be. And that's a nice community. The developers have sort of developed we'll say developed, right? Developers have developed this somewhat reliance on a lot of these tools that are first-class participants in this Positron experience. So all the things that I would expect to have available to me, version control, integration, right? We can see all of my Git information in here. Everything that I might want to have the ability to do, run debugging, things of that nature, are all part of this Positron environment. I can build all the pieces here, and then I can deploy those pieces as part of this bundle to Databricks. Once that bundle's been deployed, it can be scheduled. It's going to run. Again, that taxi data is not updating live in real time. But if I had internal data that was updating daily or on some sort of cadence, I now have a pipeline that I can put into production that's running on top of that data, adding new data. I can define expectations here. And in fact, we can see an example of this, right? I have an expectation that there's a valid date time. I have an expectation that there's a reasonable temperature. So I can define data expectations here so that if something doesn't meet these expectations, the pipeline will fail and I can be notified of it, go in and address what's going on. And all this can be driven from Positron, leveraging tools like Positron Assistant, and then pushing the outcome and the result out into Databricks. Okay, we're going to pop back into our slides here. Let's pull this open, jump back to where we were. Okay, so let's talk for just a second, and I touched on it briefly, but there's a difference between notebooks, whether it's Jupyter notebooks or Databricks notebooks, whatever the case is, and a true sort of integrated development environment. And this is not comprehensive, and I think there's reasons you'll use one over the other, and depending on what you're trying to do, there's a tool that might be better suited for the job. But there's sort of a well-known dialogue around a few common things with notebooks that you have. They're messy when working with version control because you have a lot of JSON data that's attached, versus standard Python files where your diffs are a little bit easier to understand. Working and sort of sharing code across notebooks, particularly within Databricks, can be a little bit of a challenge. Versus Python, you can structure things in modules and you can have shared imports. There's code review can be a little bit of a challenge with notebooks. Again, going back to sort of the Git diff challenges that we have there. Unit testing can be a little bit tricky, although there are some frameworks that I think can help out there. But if you're using just standard Python files, you've got access to standard testing frameworks that you can leverage to build testing around those files. Debugging in notebooks can be a little bit of a challenge. In an IDE, you have a full catalog of debugging tools that can be at your disposal. And like we kind of highlighted a little bit today, Positron Assistant does a really great job if it's going and encounters any sort of errors at addressing those errors in real time. And then we also have, notebooks are a little bit notorious for the fact that cells can be executed in arbitrary order. And so if you're not careful in the construction of the notebook, you can end up in a state where it's no longer linear. Stateless functions and the way in which a Python file natively executes can help prevent some of that from creeping in. Just as an example, and again, we're not trying to throw shade at notebooks here. This is just sort of an illustrative example of if you're looking at, for example, a code diff with a notebook versus a standard Python file, you end up with quite a lot of noise in a notebook diff versus a Python file that's a little bit cleaner to understand what's changed and what those changes might introduce. So reviewing changes through version control can be a little bit more seamless with standard Python files. You have testing that we talked about previously. You can define tests in one place in your developer environment, and those tests can then be applied anywhere those Python files run. And the idea here really is to say, look, let's have one collection of code. We can build tests around that. We can run that code in our local environment in Positron, and then we can, using Databricks asset bundles and some of these other tools that Databricks provides, we can then move that code, push that out into Databricks, and run that as part of a pipeline or a scheduled job inside of our workspace. Now, again, this isn't to say that we shouldn't ever use notebooks. Notebooks can be great for ad hoc data analysis, doing quick experiments, sharing results, right? Notebooks have a nice sort of format to them. It's a lot easier to sort of look at a notebook. You've got inline plots than it is to like look at just a Python file if you're trying to walk somebody through something. And for interactive tutorials or just kind of interacting in real time, I think notebooks provide a really great interface. But when you're doing sort of these production workloads, defining multiple different pieces at a time, building out these complex pipelines and jobs, using a true developer environment, and we think Positron is very well suited for this task, can start to have a distinct advantage over trying to consolidate and run everything outside of a notebook or collection of notebooks. So just as a review of some of the things we've chatted through today, Positron brings a very well thought out developer environment for data work to the market. And it's available on the desktop. We've used Positron in the desktop throughout this entire discussion. It's also available on the commercial side through a tool that we offer called Posit Workbench, where you can have that hosted in a server and it's accessed through a browser. So there's a few different avenues that you can take to access and get access to Positron. But on the desktop side, it's a free install that's available to anyone. Databricks asset bundles allow us to treat our infrastructure as code. We can define different components, the clusters that we're using, what files we're including in the bundle, how that execution is happening. Databricks asset bundles give us a really solid framework for defining locally what we want to run in Databricks and then pushing that compute out there. These Lakeflow declarative pipelines or Lakeflow Spark declarative pipelines help us simplify our pipeline development. We're able to describe expectations. We're able to inherit dependencies. And so this gives us a really nice framework for describing which data depends on what outputs and then where that data goes from there. And the IDE itself provides workflows that improve our reliability, our ability to collaborate, our ability to orchestrate and manage tests in that regard. And at the end of the day, the whole premise, and if you think about who we are as Posit, our goal is to support free and open source scientific research, technical communication, and data science for as long as we can. And so what that means is ultimately we want you to use the right tool for the job. And we think we've built some tools that apply in certain circumstances. There's certainly many other tools that are useful in applying this in this regard as well. So use the tool that's best for you. We think Positron is uniquely positioned to be a tool not only for data scientists, but also for data engineers working alongside platforms like Databricks, like we've demonstrated today. Before we jump into questions, just really quickly, we have some resources that we can share, the GitHub repository for this, details about Positron, and then some information from the Databricks side about asset bundles and declarative pipelines. You can visit these links and learn more. The slides are all part of the GitHub repository. So if you want kind of one place you can go and then get the rest of these resources, this GitHub repository has everything that we've walked through today. Okay. With that, let's kind of open up and see what sort of questions we have, and we'll do our best to answer those as we've got time today.